Hi, everyone. My name's Cole Tambury. I'm a rising second-year graduate student at the University of Colorado at Boulder, and I'm just going to give you a brief introduction to my poster, which you can also see on my platform, for an impulsiveness classification scheme for solar flare light curves in the helium-2, 3, or 4 angstrom chromospheric line, which has essentially comprised the last year of the first year, I should say, of my work as a graduate student at CU Boulder. Here's an image of my poster, which was presented to the AAA or AAS meeting just last week. So if you have access to that, you can check that out as well. But there's also a poster attached to this presentation, which you'll be able to look at. A quick motivation or summary for what this work was is essentially we are trying to find out why some solar and stellar flares are impulsive while others are not. And this impulsiveness, if you can see, you'll see on the poster, is defined as the ratio of the maximum irradiance of a flare light curve uh, in a certain line divided by the full width at half height in time. So the peak irradiance divided by essentially a duration parameter. The result is that a high impulsiveness flare will have relatively high or peak irradiance or a relatively short duration, whereas a low impulsiveness flare will have a relatively long duration relative to its peak irradiance. We developed this classification based on a stellar flare classification, which has been done previously, but this hasn't been associated with solar science quite yet, and then compared to a number of other flare quantities and applied to an entire database called the RibbonDB database, which comprises about 2,048 flares, which we look at. We also use the SDO AIA 1600 angstrom data to study morphological variations with impulsiveness, and I'll show the results of that a little bit later. So a brief introduction also to the relation to other flare quantities. We compare this impulsiveness index to the flare duration, quasi-periodic pulsation period, reconnection rate, and a number of other quantities. I've shown two here. On the right, you can see a log-log plot of the impulsiveness versus flare duration. Obviously, there's a relationship here, and it makes sense that there would be a power law because the duration is essentially the denominator in the calculation of impulsiveness. A similar relationship exists with QPP period, which are provided by Laura Hayes. We also compare to the maximum reconnection rate, which is less intuitive, but there does seem to be a slight relationship where high raw impulsiveness tends to correspond to high positive maximum reconnection rate during the impulsive phase. So it's a little bit less strong, but it does still exist. Finally, we also studied the morphological variations using the 1600 angstrom images taken by SDO AAA. A movie of this is shown. I'll show this on the right. On the left, you see the integrated flux counts for normalized as well for the 1600 angstrom line in violet and purple, and in the black line, you see the 304 angstrom line provided by SDO Eve. So we use these movies like this to essentially take a look at relatively high impulsiveness, relatively low impulsiveness, and other interesting flares for whatever reason. And we can essentially see whether, for example, multiple peaks in impulsiveness or in the light curve are associated with the same part of the solar flare or different ones. We can see what the morphological variation is for relatively low impulsiveness, such as this, or a relatively high impulsiveness flare, which you can see on my poster. So we can study a lot of interesting things, not just in terms of the full disk or the sun as a star light curves provided by SDO Eve, but also by the full disk images to get a better picture of how this is changing. And this essentially is what we're trying to do with this, where we're trying to take impulsiveness, compare it to another of other quantities, see how the relationship works out, and then try to apply this to stellar flares where we might not have the same amount of information which we have for a solar flare. So to try to understand how impulsiveness relates to a number of other quantities on both the sun and on other stars. Thanks, and if you have any questions, you can contact me via email or during the summer school. Thanks.